Hi guys, Mr. Bennett here. I just want to talk through exercise 2G3, the concept of a rate of change. So if you're looking at average speed compared to the instantaneous speed, they are quite different. So I know you probably have had this discussion in physics last year for those people that did physics, but you could be driving along and your average speed might only be 80, but you might be speeding, at 140 at one stage. And so if you pass a policeman, the policeman, if they saw you doing 140, are going to book you for speeding, and you'd probably lose your licence. Even though your average speed over the trip might only be around roughly 80 k's an hour. Now, to work out the instantaneous speed, what we need to do is we need to work out the tangent at that particular time. So I'm going to show you a little demonstration I think will hopefully help you. And this is the concept when we start looking at calculus, which is our major topic this year. Alright, so if I want to find the rate of change between this point here, which is 1, 1, and the point up here, which is, I think, what is it, 3 point, I can make it maybe 4 or something like that. Anyway, the point shown over here. If we want to know the rate of change from that point to there, what we do is we do a straight line. And if you've got 2 points, then you can find the slope of the line. And the slope of the line is the rate of change from one point to the next point. The thing here is, I need 2 points, don't I, to actually find the rate of change. If I want to know what the rate of change is at 1, 1, then what I could do is I could move that point closer to 1, 1. So you notice as I'm moving that closer to 1, 1, what's happening to the slope? Have a look at the slope. I'll move it a little bit closer. Slope seems to be decreasing, doesn't it? Right, it's going to 3. Now it's below 3. It's getting closer and closer to a point there. And what have we got here? We've now got the tangent at that point. That there is the instantaneous rate of change of, it could be velocity or whatever what we're looking at. Alright? So if we were using the example of a policeman, you're driving along, that's what he's taking he's taking a reading on with his radar gun. Right? He's looking at your instantaneous rate of change. Now your speedometer in your car does that. It actually works out the instantaneous rate of change. Right? So that is the speed that you're doing at that particular time. Right? Not your average speed, but your instantaneous speed at that particular time. So the tangent tells us the rate of change at a particular instant on the curve. Now, if I obviously move that point up there, that's got a steeper slope, hasn't it? As we move around this particular point. But because we're looking at finding a slope at this particular point here, then that's what we'll actually find. So over the next couple of weeks, that's what we'll be looking at. We'll be looking at finding the rate of change at a particular point using calculus. And the limit, this concept of the limit as we get closer and closer to the point is a really important concept. And we're going to use that in the proof. We can also come this side as well. We're going to use that in the proof, and we're going to do a thing called first principles to prove what's going on over here. Alright, so this is just to give you a bit of a heads up about where we're going with the theory, and this is the concept of the limit. Right? As the limit gets closer to the point, because you need 2 points to find the slope of a line, we can actually make the limit go to 0, and if that value is 0, then we actually have the rate of change, instant rate of change at that point. In other words, we have the slope of the tangent at that point. Alright, we'll talk to you guys later in class about this, so I look forward to talking to you about this stuff in the next video.